Hey guys, welcome back to our segment routing traffic engineering series. In the past of couple of the episode, we have been talking around or working with the TI-LFA. That is topology independent loop free alternate, So the whole idea is just to trying to figure out the backup path which are free of any kind of a loops. And in couple of the past episode, we did hands-on and we saw the examples around zero segment and a single segment example. And we will continue the conversation in this episode around double segment or two segment example. So if you recall the two segment example or the double segment example, that means now if there is a failure experienced on the primary path, the backup path would have two extra instructions or two additional labels to reach from a given source to our given target. So for this, I went ahead and built up a new topology. So we have 6 router here, 1, 2, 3, 4, 5, and 6. So in this case, router 1 will be our source router and router 2 will be our destination router. Now, from the source to the destination, this is the shortest path. That means the router 1 will always take the gig 0 link to reach to router 2. Why? Because we have the metric as really 1 here. And all the default links has a default metric of right now 1. In this lab, we will also go ahead and try to play around the metric of the link, and we'll go ahead and tweak the metric on some of the link, or if not all the link, at least in one of the link, and we can go ahead and change that either between router 4 and 5 or router 5 and 6, depending on that. We'll go ahead and make that change. And then we'll take a look at, the overall, the metric, and again, to see all those overall metric, we can take a look at inside our rib table. And that's where we'll go ahead and take a look at, some of the things. So now, right now we are on router 1. I just went ahead and enabled a very basic segment routing. And if you take a look at the MPLS forwarding table, this router 1 sees a prefix set for label router 2, 3, 4, 5, and 6. And as you can see, for the 6, it has two possible paths. That's what it says. Okay, hey, we are on router 1. It says to reach router 6, I can either take the gig 0 because this is link 1, 2, 3, or I can take this path 1, 2, and 3. So for router 1 to reach router 6, it has a kind of symmetric path. Either both the paths are pretty much the same. So that's why it can take either one of the path to reach from router 1 to router 6. But for our hands-on or for TI-LFA double segment or two segment example, we will be using router 1 as our source and we'll be trying to reach to router 2. That will be our destination. And at the moment, if we go ahead and take a look at our route table, and the route we are looking is 192.168.0.2, which is the loopback IP address of our router 2. So let's go ahead and take a look at in this case. And as you can say, it says, hey, simply, this is right now the metric for this router is 1. It's a labeled SR. Type is level 2 because we are running ISIS, and it says right now it is taking this particular path to reach to router 2 from router 1. So we do not have any kind of a backup path or anything which is configured. And we can also go ahead and verify the same thing by looking at the fib table. So show ceph 192.168.0.2/32 in this case. And let's go ahead and take a look at. So that's what it says. Okay, hey, this is the path that it is kind of primarily taking. And this is the link that it will be taking. And the local label to reach to node 2 is 16,002. So when sending the traffic, there are no labels being imposed because they're implicit null because they are directly connected. So PHP happened here. So this is only the local label. When sending the traffic, there will be no label to this particular route right now. And we can also go ahead and take a look at our fast reroute again, if there is anything. So I can say show ISIS fast reroute and 192.168.0.2/32 in this case. And as you can see right now, there is only one link from router 1 perspective to reach to router 2. And there is no backup configured. That's what it says. Okay, hey, there is a basic sRGB block of 16,000. And as you can recall, configuring a TI-LFA is very simple. To configure the TI-LFA, we would have to go inside our IGP. So let's take a look at what is the current configuration we have under our IGP. So under IGP, we do not have any configuration for TI-LFA, and we are interested in trying to figure out a backup path between router 1 and router 2. So let's go ahead and configure the TI-LFA. So we go under router IS1, and within the router IS we are interested in gigabit Ethernet 000. So let's go interface gigabit Ethernet 0/0/0. Now, if you recall, any time when we configure TI-LFA, we would need to go inside the address family, and then there we have to go ahead and configure. So address family IPv4 unicast. And again, the command was fast readout. We can configure the fast readout based on either per link or based on per-prefix. In our case, we have been primarily working with per-prefix, and we will continue the same. So we'll say per-prefix. And for this per-prefix, we want to go ahead and make use of the TI-LFA as the computation algorithm or the mechanism. So we are retyping the same command fast readout per-prefix based on TI-LFA. And that is the only configuration that we need to configure or need to enable TI-LFA on this particular path. So let's go ahead and commit our change. So we went ahead and committed our change here. And now if you come outside and if you go ahead and take a look at some of the things. So let's go ahead and take a look at the route table here first. So we are interested in taking a look at our route table. And route table is, guys, show route. So now we are taking a look at our route. From router perspective, we are saying, okay, hey, show me a route to reach to 192.168.0.2/32. And let's go ahead and expand here. Now, if you notice here, whatever route we had earlier, now we have one more route here. And for this route, it says, okay, hey, this is the route. 10 from this to this, primarily, it will be taking the gigabit Ethernet 001. So that means it will be trying to take this particular path here. Now for this path, it is a TI-LFA path and it's a backup path. That is the reason our primary link became protected. That means, hey, this link is a protected, means if this link happened to fail, we have a backup path already installed, and it would be just a matter of milliseconds to switch from this path to the second path. But if you take a look at the metric for this path, the metric for this path is right now 5. Remember I said we have not made any change to any of the metric. So all the path has the same metric. So 1, 2, 3, 4, and 5. So that means if we are taking this, it would be 5 metric. So let's go ahead and change a metric value and then take a look at it again. So we'll go to our router 5 and we'll try to change the metric value for this gigabit Ethernet link 0. So let's log into router 5. And if we take a look at the interface, we are interested in changing this for link 1. So if I go ahead and do a show run quickly here, just to make sure that we are okay. So the link, this is gigabit Ethernet 001. Okay, so now let's go inside the configure. We do segment routing traffic engineering. We'll say interface, and the interface we are interested is gigabit Ethernet 001. And now we'll go ahead and say the metric. And again, we can go ahead and change the metric to whatever value we want. So let's go ahead and change the metric to 100 here. And let's go and commit the change. And now if we come back to our router 1 again, and let's rerun the same command one more time. Now again, the TE metric is still 1. We have not made it, because what we just changed the TE metric. We have not changed any other thing, guys. Okay. So what it shows right now, okay, it shows here is the IGP metric. In this case, it's okay. This is the 5 node. It needs to cross. Beyond that, not really anything here. And again, we can go ahead and change any other things that we need to go ahead and take a look at here. So now this is the backup path. Now let's go ahead and take a look at our fib table. So if you come back and if you remember the command to look in the fib table, yes, using the show ceph. So if we do the show ceph again, and what do we see here right now? What it says, hey, this is our backup path. And the point of the repair node, it talks about this would be our node point of repair node primarily. And if we take a look at here, it says to reach to 16,002, it is sending the traffic to 16,016. So now, okay, hey, it is sending the traffic directly to this particular node, which is node number 6. And then from there, it is sending the traffic to 2. But if you take a look at the example here, this is not really 2 segment. It is only trying to make use of 1 segment here. Okay. And we'll come back and take a look at on this one. And now at the same time, let's go ahead and take a look at the show ISIS fast reroute here. Now if we do a fast reroute here, and in the fast reroute, if we take a look at here, it clearly says this is a backup path, and it says, okay, hey, it is right now using only a P node, and the P node in this case is router number 6. That means from this router 1's perspective, router node 6 is the P node. That means it will use the prefix SID to come out of this failure. It'll go to this node, and from there it'll go ahead and make use of this prefix label to reach the destination. Okay, but we do not see the 2 segments here. So as you can see right now, we verified that there is only one extra label or another instruction was added. So if I go ahead and simply show you one more time the route table here, and in the route table we could see some of these information. Let's take a look at the fib table. That gives us the good information. So in the fib table, we could see there is only one label is being included here. So that label is for P node. And if you remember, in the case of the 2 segment, we had talked about, okay, hey, they're going to be a P node, and then it will probably use a adjacency SID to reach to a Q node, and from there it will go ahead and route our traffic. So in our queue, what's happening in this case right now, because all the link has a default metric of 1, and that's why it is able to reach directly the router 6. Now we want really to make it 2 hops. So what we'll go ahead and do in this case, that will go ahead and increase the IGP metric. We tried increasing the T metric, and you see the T metric has no effect on in any of these things, because it is using the IGP metric to reach from this source to this destination. So now we will go ahead and change the IGP metric in this case between router 5 and router 6. So what's going to happen in that case, right now if you see, the router 1 is reaching directly to router 6, and after reaching router 6, it is reaching to our destination, which is router 2 16,000. Once we go ahead and increase the metric between, let's say, router 5 and router 6, now our router 5, now in the present case, the router 6 is our P node, but once we increase the metric on this link, the router 5 is going to become our P node, because by default it is not going to take or try to use the link which has a higher metric, and in that case it will go ahead and probably send the traffic back and try to create a loop. So once we go ahead and increase that, now it needs to figure out a path once we reach to this P node. Now from this P node, the whole idea is, okay, we do not want a loop. So that means if it tries to send the traffic back, it will potentially create a loop because this link is already down. So this node now needs to send the traffic to this particular node. And in that case, to reach from node 5 to node 6, instead of using the prefix SID, because if you are using prefix SID, again, as I said, there is a chance that this router 5 might send the traffic back onto this link, because this link has a lower metric of default 1 versus, let's say, the metric that we'll go ahead and configure on, let's say, on this link is 200. So in that case, router 5 by default will never prefer this one, and there is a good chance that it will go ahead and send the traffic back to this one. So that's the reason we'll not go ahead and send the traffic to this router 6 using its prefix SID, but router 5 will go ahead and make use of this link's adjacency SID to forward the traffic from node 5 to node 6. That means from this P node to this Q node, and this Q node has a capability or knows a way how to reach the destination. And as you can see right now, that's not happening because I said all the links by default have same metric. So now we'll go ahead and tweak the IGP metric on router 5 for our Gigabit Ethernet 001. So let's go ahead and log into router 5, and we are not making any change to router 1, guys. Again, just to show you the Ceph table, this is our current Ceph table. It says, okay, hey, if this link fail, I would go directly to 6, and from 6 I will send it the traffic to 2. But we do not want that to be a single segment. We want it to potentially be 2 segment or double segment in that case. So that means we want router 1 to send the traffic potentially to router 5 first. So that becomes our P node, and then using the adjacency SID, send the traffic from node 5 to node 6. And once the traffic reaches to node 6, from node 6, you go ahead and take the prefix SID of our destination and send the traffic. So let's go to our router 5 and let's try changing the metric for this link. So let's go to router 5 quickly. And as you can see on router 5, this is our current ISIS. So in the case of ISI, we need to go ahead and change the IGP metric, and IGP is ISIS. So now let's go to router ISIS 1, and the link that we are interested in is Gigabit Ethernet 001. So let's go interface Gigabit Ethernet 000, and guys, all the metrics are configured under address family. As you can see, the default metric value is configured here, the value of 1 on these routers. So we'll say address family IPv4 unicast, and we'll say metric, and let's go ahead and change the metric to 200 in this case, and we go ahead and commit the change, and let's come out and let's verify quickly the router ISIS process one more time. And as you can see, okay guys, my bad, I ended up doing this on Gigabit Ethernet 0 while we need to do this on the Gigabit Ethernet interface 1. So let me go ahead and change that, and I'll say address family IPv4 unicast, a metric of 1, but on interface Gigabit Ethernet 1 we want to change that to a higher value. So let's say the metric is 200 in this case. Commit the change, come out, and let's go ahead and take a look at quickly our router. So now the link between node 5 and node 6, we just simply went ahead and changed the IGP metric. That means, hey, this is a path which is a higher metric versus this path which is a lower metric. But if you end up taking the path which is lower metric, that means it will go ahead and create a loop, and which we do not want. That's the reason we have a TI-LFA. But now because this link has a higher metric, so in router 1, instead of sending the traffic directly to router 6, it will go to router 5. It will say, here, I'm sending you the traffic. So you become my P node. Now you need to figure out a way to come out of this particular failure. So in that case, the router 5 will say, okay, if I go back and this path, it will go ahead and create a loop. And I cannot reach directly to 6 using the prefix SID, because if you take the prefix SID, that means it will always try to fall back to the lower IGP, which is again this path. So in that case, it will go ahead, instead of using the prefix SID, it will go ahead and make use of the adjacency SID for this link and send the traffic from router 5 to router 6. Our router 6 becomes our Q node. And guys, if you remember, to reach a Q node, we make use of the system, or the TI-LFA make uses of the adjacency SID. So once the traffic reaches your Q node, which becomes router 6, it will go ahead and send that traffic to your destination. And now that's the change we made. Now if you come back to router 1, and we have not made any config change or anything to router 1. And if you simply go ahead and rerun this command again one more time, and if you take a look at here, there is a slight change. As you can see, before we had the same metric value, there were only 2 hops. So that means it was a single segment example. Now you see we have another segment or another instruction that got added, and that is the adjacency SID. So that means now the router 1, if there is a failure to reach to 16,002, router 1 will send the traffic. The very first instruction it appended on top of the original instruction is, hey, go to router number 5. So it will reach to router number 5. And then router number 5 will go ahead and make use of the adjacency SID to reach to router 6. And once it reaches router 6, it will go ahead and make use of the prefix SID of your destination. It will go ahead and send the traffic here, guys. Okay. So now again, just to confirm and see the higher metric, we can again go ahead and take a look at in our rib table by doing the show route command. And as you can see, for our backup path, now our metric is 204. And for our primary path, the metric is 1. Now let's go ahead and take a look at that fast reroute and take a look at now the P and the Q node. So now if you go ahead and run this command, and if you take a look at here, it says, okay, I have figured out a backup path, okay. And that backup path will go ahead and make use of the Gigabit Ethernet link 1. And the metric on that link is 204. So in that case, it says, okay, hey, the P node, our P node is our router number 5. So that means this is the first additional instruction that was appended to our original packet or original label stack. So now it will go ahead and send the traffic to this P node. So this P node is our node number 5. So router 1 will send the traffic first to node number 5. And then from there it says, okay, hey, go ahead and go to the Q node, and to reach to the Q node, guys, again, we make use of the adjacency SID. So we are making the use of this adjacency SID 24001. And once you are on the Q node knows how to send the traffic to the destination. And after that, it is going to go ahead and make use of the prefix label. So you can see in this case, there are two additional labels. There were two additional labels were appended to our original label stack. And that is primarily the example of the double segment or two segment example of TI-LFA, guys. So when we had all the link to the default metric, that means the router 1 can reach anybody because all the links primarily have the same metric. So in that case, it ended up picking router 6 as the P node. And then after reaching this P node knew how to send the traffic to our destination. But once the metric for this link was increased, that means it becomes a least preferred path because of the higher metric. Router 1 ended up picking router 5 as the P node, and it says, okay, hey, now you go ahead and figure out how to come out of this failure. So the router 5 ended up picking the adjacency SID to reach to the router 6. If we had, instead of using the adjacency SID, if we tried using the prefix SID, there is a potentiality or there is a possibility that router 5 might try to send the traffic back to this link, because this link has a least or less metric value here. So that means it becomes a preferred path, but if it ends up sending the traffic to this path, it becomes a loop. So TI-LFA is trying to avoid that for us, saying, okay, hey, now instead to reach from node 5 to node 6, go ahead and make use of the adjacency SID. And once you are on the Q node knows how to route the traffic to our destination. I know, guys, there is quite a bit of information for you to process in this particular episode, but yeah, take a look at some of these examples, and again, if you have any doubt, go back and take a look at the theoretical concept video, or take a look at the slides which are available on segment-routing.net. Thanks to those guys again putting such a wonderful material. You can go ahead and refer that, and that's what we are seeing in this case. Okay, hey, to reach to the P node, we make use of the prefix SID, and to reach a Q node, we make use of the adjacency SID. That's what we have learned during the theoretical concept, and that's how we went ahead and proved here also that, okay, hey, once we change the metric, now the TI-LFA ended up picking node 5 as our P node, and then the link, it used the adjacency SID to go from node 5 to node 6, and node 6 became our Q node, as you can see even from the output. And then this node 6 or the Q node knew how to route the traffic to our destination, and so it ended up sending the traffic. So that'll be all for this episode. Again, if you have any questions, do leave me a comment. I will try to answer. But yeah, try doing some hands-on around this to really understand all that concept. So that'll be all for this episode. I will see you guys in the next episode. Thank you.